This is the Physics Lab 3, Absorbance and Fluorescence. To start, the purpose of our experiment was to identify an unknown dye solution based on its absorbance and emission spectra, and we also need to identify the concentration of it. Later on, we had to identify the absorption curve and emission curves for fluorescent dye. So our experimental design is we had a flashlight, we had a cuvette with different kinds of solutions in it, and a spectrophotometer hooked up to a program that would detect light and measure it out in different peaks. So for our first model, again, we have light on one side of the cuvette and a detector on the other. This is how we measured the transmitted light. So for our second model, this is more towards the fluorescence, but we have photoactive molecules, and as you add energy and you excite them, their electrons jump up energy states and get excited. And as they drop back down, they emit light via photons of different nanometers and different colors. So here's our cuvette with water transmission curve. And we had, again, a light on one side of a cuvette with just water in it and a spectrophotometer on the other. And this is the wavelength curve that we got. Now here we have a purple solution, a purple dye solution in a cuvette instead of the water. And we did the same exact setup, except here's our curve, so there's a lot less light transmitted directly through, even though it's the same light source. So using those and other mathematical values that we got from the computer, we calculated our absorbance for the purple solution. So this one is based on, we took the water transmission curve and subtracted the purple solution curve, and actually the values in Excel, but they're all based on the same data. And we calculated this absorbance curve, which is the difference, and this is what the dye absorbed and didn't transmit out. The other way that we did this, and actually the initial way that we did it, is we calculated it using the equivalent that absorbance is the log of I naught over I, with I naught being the original intensity, the water in the cuvette, and I being the intensity of our purple dye solution. And so granted, the intensity on the left side in the absorption doesn't really match the other curves, so that's our one kind of issue with this. However, the peak is pretty perfect compared to the reference dye curves that I'm going to show you in a second. And so we didn't calculate this incorrectly, it's just a different way, so we still like to keep it because it gives us the data, but not incorrectly. So here's our known absorption spectra. This was in our pre-lab. And we had to use this to identify, based on our absorbance curves, which dye we had. And now in both of our absorbance curves, they peaked around 550 nanometers. And so that matches pretty well with this Lepidus dye, and that's what we've identified as the identity of our solution. And so the Lepidus dye has an epsilon value of 43,000. This will be important in a second. We interpreted this by using Beer-Lambert law, where absorbance equals the molar extinction coefficient, or epsilon, times the concentration times the path lengths. And our path length is only 1 centimeter. We know our absorption, and we know the molar extinction because we know it's Lepidus dye, so we just need to solve for concentration. So using that math in Excel, we figured out this is our concentration curve of the purple dye solution, and the max is 0.002 molars. So we said that since that was the max, that the unknown dye concentration was approximately 0.002 molar, and we did know it was Lepidus dye again as the identity of it. Our graph showed the absorption spectra of our unknown dye, and this was using the spectrophotometer again, and we had no other information about the dye besides what we were given. And so now for our fluorescent, this is the absorption curve for that, and in the visible light spectrum, this is what we got to calculate to be the absorbance. Here's the emission curve, and granted they do look identical. However, I should point out that the data in the Excel sheet, they are different values, they just look very similar, which we reconcile because as you absorb the correct or sufficient amount of light and energy, the photoactive molecules can get excited and then drop down and emit these great fluorescent lights and wavelengths, so that's how we reconcile that. Some errors we noticed was the light pollution from other sources. The mag light wasn't always the identical intensity. Oil on the cuvette could have changed it, and inconsistency in the placement of the detector. Thank you.